In this video lesson, we're going to talk about elastic energy. And so elastic energy is the energy due to deformation. So this could come from stretching or compressing or from twisting. And so the symbol for elastic energy is E. So there's a little E, okay? All right, so then when we're using elastic energy, we have a formula for elastic energy. And so our elastic energy formula is 1/2 K delta X squared, okay? And so with our elastic energy formula, there's a couple of things that we can talk about in terms of what they mean. So EE, of course, stands for elastic energy. And that's going to be measured in joules, just like we measure every type of energy, okay? The K in this formula is called the spring constant. And so that spring constant is a constant for every type of spring. And it's sometimes called the stiffness of the spring, okay? And so either you're given the spring constant or you'll be asked to find the spring constant, okay? And then delta X is the deformation of the spring. And that's going to be measured in meters, okay? And then it needs to be squared as well. So this is how much the spring is compressed or stretched by. So this is the deformation. So how much it was stretched or compressed, okay? And so we are going to do some practice questions with elastic energy. So with our practice number 1 here, we have a spring-loaded toy. Uses a compressed spring. To fire a marble out of a tube. A force of 220 newtons compresses the spring by 0.14 meters. Calculate the elastic energy. Okay. So with this question, we also need to think about the spring force. And so I'm going to introduce a new equation here as well. So the force of our spring is actually equal to K times delta X. And this is a special equation. It's called Hooke's law. Okay, so with Hooke's law, we have the force of the spring is going to be our spring constant times the deformation of the spring. So delta X is the same there. So what that means in this question is that we have the force of the spring, so 220 newtons, will be equal to our K times the deformation of our spring, which was 0.14 meters. So that's going to allow us to calculate our value for K. So that's going to be 220 divided by our 0.14. So we've got a spring constant of 1,571. And the spring constant unit is actually in Newton meters. Okay, so it's in newtons per meter. And then we're going to use this to be able to calculate our elastic energy. So elastic energy is 1/2 K delta X squared. So we do 1/2, our K value is 1571, and then our delta X is 0.14, and that's going to need to be squared. So our 0.14 squared times our 1571 times our 0.5 gives us an elastic energy of 15 joules. Okay, so then we're going to try, I think, 2 more questions. So we'll do another practice. So we'll do practice number 2. So in this one, calculate the elastic energy for a spring with a spring constant of 5.5 times 10 to the 3 Newton meters. When it stretches, there we go. So in part A, if it stretches two centimeters, or in part B, if it compresses 3 centimeters. Okay, so in part A, if we want to calculate the elastic energy, we use 1/2 K delta X squared. So 1/2, our K value is 5.5 times 10 to the 3. And then remember, our delta X needs to be in meters, so 0.02, and that's going to be squared. So our 0.02 squared times our 5.5 times 10 to the 3 times our 0.5 is giving us 1.1 joules. And then in part B, instead, we are compressed by 3 centimeters. We're using the same equation. Our K value is 5.5 times 10 to the 3. It's still the same spring. Only now we are compressed by 3 centimeters, so 0.03 squared. So we're getting 2.5 joules. Okay. And then I think we're going to try one more practice question here. So practice number 3. All right. So a spring has a constant of 1.5 times 10 to the 3 Newton meters. Find the length that the spring should be stretched to store 80.0 joules of energy. Okay, so we're using our new formula here. Elastic energy is equal to 1/2 K delta X squared. And so our elastic energy is 80 joules. Our spring constant is 1.5 times 10 to the 3. And we are looking to solve for our delta X. So we're going to do 80 divided by our 1.5 times 10 to the power of 3. That's multiplied by 1/2. And so that's going to give us 0.1067 equal to our delta X squared. So then we're going to square root. And so when we square root, our delta X is 0.33 meters. Okay, so that means that we should compress the spring or stretch the spring by 0.33